Namaste friends, welcome back to this fifth lecture on the course on psychology of language. Now, the highlight of today's lecture, which is the fifth lecture, and the one to follow this one, which is the sixth lecture, would be on speech production, which is how do we produce speech. The talking that we do, how do we do that? What we will unfold in this lecture is the very basic. So, please understand that this is not a linguistic course, and so we will not go into too much detail onto the linguistic aspect of speech production. So, we will just look at the psychological aspects of language production or production of speech, and so we will be quite restrained in our explanation. But before we start unfolding the lecture, as I have been doing in the past lectures, let us look at a little bit from the past lectures, that is 1, 2, 3, 4 lecture number, and that also helps you in getting the context of these lectures. So, each lecture getting into the context. So, the psychology of language, as I said, is a course which looks at the psychological aspects of language. So, obviously, in the first two lectures we tried to define what is language. We started off by explaining the basic form of language, which is animal communication system, and we looked at what are the characteristics of this animal communication system. Since animals communication is the very primitive language or the very basic language. Now, as we said there, it is a very basic system which can only express a few ideas. So, we looked at that. We looked at why do animals communicate, and we looked at some characteristics of this language system. Then we moved on to the idea of human language. We saw how human language is different from animal language. So, basically the characteristic features of human language, namely that it can produce a multitude of ideas and it can have a structure which is recursive in nature, which provides it with the flexibility of expressing within few limited basic structures the whole language itself. So, we started looking at human language and we started distinguishing between human language and the animal language. We then looked at the characteristics of human language. We looked at things like the various modes of human language and the idea of duality of patterning. We looked at how the human language is built, right from the basic speech sound to the idea of morphemes, to the idea of word, sentences, syntax, which is how the words should be arranged, grammar, which is the rules that a language should follow, then the idea of discourse. So, we looked at all those structures of how the human language is arranged. We also looked at certain rules of the phrase structure rules and how within a particular sentences certain parts of the language or certain words can be rearranged. Then we focused on the fact of how language evolved. So, we saw how the Neanderthal mans, the Homo sapiens, they came across and how they had developed this idea of language, and we looked at the continuity and the discontinuity theory of language, which basically says how language evolved. And after that we moved on to, and so we looked at several evidences of both the continuity and the discontinuity theory, and then we looked at the fact of how the fossils of language, the living fossils of language, basically how language was described to have evolved from the proto language. The idea that the present human language, which is complex in nature, how it evolved from a proto language or basic language. So, there we investigated the idea of pidgins, which are primary form of language, which do not have too many words into it, too many complexities into it, but can be expressed for expressing ideas. And we looked at how this language teaching research has been done across various scientists, and how some basic language, human language, were taught to chimpanzees, and how chimpanzees and human were difficult. So, the idea of Chomsky, which says that humans have a language acquisition device, against the idea that animals do not have that kind of a thing. So, we concluded the chapter there with this debate. Lecture number 3 and 4 was explicitly focusing on research methodology into language. So, we explained what is the way of doing research in language. I explained in detail what is the scientific method, what is theory, what is hypothesis, how theory, hypothesis, observation and patterns they interact together to form the research cycle, and the idea of how induction and deduction works into the research cycle, and how we build models to explain certain hypothesis or certain predictions of the theory. We looked at the idea of experimental design, how there are the between subject and within subject designs, and what are the IVs and DVs and those kind of things that we looked at. We looked at behavioral techniques of doing language research, in which we primarily looked at latency, which is the reaction time, and accuracy, which is the correctness, as dependent variable measurement or as choices of measurement variables in most language researches. We looked at several examples in terms of the lexical decision task, and several other examples there to explain in detail what we have been covering or what we have been talking about. And lastly, we looked at the language and the brain, how the brain and the language are integrated together. We focused on certain regions of the brain, certain areas which are dedicated to language, and we looked at certain equipments, techniques like EEG, MRI, fMRI, and how these techniques are used for studying language or for completing a research on language. Now, today's lecture would be an interesting lecture, where we look at how do humans produce speech. The way I am speaking to you, how do I produce this speech? So, to start today's story, we will go back to the Haskins laboratory, where the first artificial speaking machines were designed, and these are called the pattern playback machine. Now, these pattern interest in language, of how language is produced, is has been around for quite some time. And just after the World War I, Haskins laboratory produced an artificial language machine, which was called the pattern playback machine. Now, of course, this machine had no vocal cord, no mouth, and other language equipments which human have to produce speech. But what this machine was able to do was produce some basic frequency sounds, and these basic frequency sounds, when they were put together in a sequence, it sounded like the human language or the human speech. That was the beauty of it. So, but it could produce only very basic speech. So, even these sounds which are produced by this machine, when they were arranged in complex pattern, it could not be matched exactly to the way humans produce the phones, the basic speech sound, but it was much closer. So, humans, when the playback machine were played back to the artificial machine was played back to humans, they could hear, or they could promise that they hear some basic speech sounds. That was the first attempt. From then, which was just after the World War II, to presently, we have much dedicated systems which produce artificial language. We have Siri, we have the Google Assistant, which can not only understand, but also listen to you and then respond to you. So, the first machines which were producing just specific frequencies which uttered when uttered through this complex arrangement of sounds sounded like human language, to the present world Google Assistant which you can talk to, and not only it produces sound which you can hear and understand, it can also understand what you are saying and comprehend meaning out of your speech. So, vast area. So, let us look at some of the psychology behind the speech perception. We will start by looking at how language is, what is the very basic uh, item or element in producing of speech. And so, the very basic element in auditory perception is the speech sound, the look of speech. So, how does sound look like? Now, as you know what is sound, the ear actually when you produce speech, there is a pressure difference which is created, and this pressure difference it moves in terms of waves across the space between two people, one the producer of the speech and the other the receiver of the speech. And when it hits the ear, which is the perceiving mechanism for the other person, this is decoded back, this pressure or this wave which is travelling, and meaning is extracted out of it, or people understand that. The producing system is the vocal cord or the vocal fold and the mouth, and the receiving system is the ear. So, we will look at these two systems, but even before we do that, what is used to transfer this vocal fold vibrations is the wave, the sound wave. If you ever so how do you explain this wave? If you ever sat near a pool of water, taken a rock and thrown it into the water, you will see patterns of high pressure area and low pressure area, or certain patterns moving away from the point of impact of the stone, and this is what a wave is all about. And this is how the sound wave also looks like. So, any wave, a wave is basically the highs and lows of pressure. So, when we speak, what we are actually doing is that there are air molecules between our mouth and the other person's ear, and so these are air molecules are vibrating in a particular frequency. And so, when we speak, what happens is the vibration changes in a certain way, and so it travels in the form of a wave. Now, any wave, so basically sound is a wave. So, any wave has two fundamental things, or there are two fundamental properties of any wave. The first is called the frequency of the wave. And so, what is the frequency? It is the number of wavelengths that pass by a given point in a given amount of time. So, if this is my measurement axis, or this is where I am doing the detection, and let us say this is my time axis. So, let us say from 0 to 1 second, the number of times, this is 0 second and this is 1 second, the number of times this vibration is there is called the frequency. So, number of wavelengths, this is 1 wavelength, this is 2 wavelength, this is 3 wavelength, 4 wavelength, and so on and so forth. So, the number which is there, that gives the amount, and this is measured in cycles per second or hertz. How many cycles? So, this is 1 cycle, this is 2 cycle, this is sine wave, right. A sine wave starts at the 0 epoch, goes to a maxima, a local maxima, comes back to the baseline, goes back to a negative a minima, and then comes back to, this is what a sine wave looks like. I am pretty sure you must know what a sine wave is, and so most sound waves are considered to be sine waves. So, basically a wave is explained then in terms of how many waves or how many wavelengths pass a given point. This is my point axis, detection time, and in 1 second how many of them are passing. Let us say there are 15, so it is 15 cycle per second or 15 hertz. The psychological perception of sound wave frequency is called a pitch. So, what we call frequency in the physical domain is called a pitch on the psychological domain. So, when we talk about pitch, it is how many wavelengths are passing a particular point of time, a particular point of detection in a particular period of time. So, this is the first thing you should know about a wave, and I am pretty sure you know these things. So, we are just repeating these things or we are just adding on to it. The next thing that you should know about a wave is the amplitude. This is the height of a wave from the baseline, the deviation from the baseline. So, amplitude is the amount of change that a wave undergoes during one cycle. So, wave starts here, goes to a maxima, goes to a minima and comes back to the baseline. So, the maximum change that it is facing this point to this point is called the amplitude. This is also in terms of sound wave, the difference between the highest pressure and the lowest pressure or the sound wave is called the amplitude of that wave. So, the amount of change that wave undergoes in one cycle is the amplitude. These two things are very necessary, the frequency and amplitude, and most measurements of wave are done on this basis only. So, on the physical domain, this is called the amplitude. In the psychological domain, this is called loudness. So, what you call amplitude in physical domain is loudness in the psychological domain. Now, these two properties, the amplitude and the frequency, it describes the sine wave, so called, a sine wave is so called because it is a wave that can be described by a trigonometric function which is called the sine function. So, sine waves, why do we call a sine wave a sine wave? Because it is basically can be explained through the trigonometric function of sine. Now, some other things that we need to know. We need to know what is the fundamental frequency of any wave. If you take a rubber band and put it across your two fingers and pluck it, bring it near your ears, it will produce a sound. You will see the rubber band vibrating. The vibrations which happen across the entire length of the rubber band is called the fundamental frequency. So, vibrations along the entire length of the string or rubber band generates the fundamental frequency, and which is also the lowest frequency produced by the vibrating object. Now, since it is for the entire length, obviously the amplitude has to be less. So, this is the low frequency, since across the thing. So, the frequency will generally be 1, and so the low frequency produced by vibrating object is called the fundamental frequency. But when you look at a vibrating object, this object does not only produce waves across the entire length, right. Vibrations also happen at half the length and then 1/4 the length. So, when you have a vibrating object or a tuning fork, this is my fundamental frequency, this is another frequency and this is another frequency. So, this is the full length L0, this is L1 and this is L2. So, L2 is 1/4 of L0, L1 is half of L0 and L0 is of course L0. Now, this type of frequencies, vibrations at half length, third length and so on, generate what are called the overtones. So, if you have a guitar and a violin, they sound different because although the fundamental frequency. So, if they are playing the same string, say A minor or something like that, although they are playing the same sound, they sound differently because they have different overtones, the length are different and so they produce different overtones. So, higher frequencies are also produced by the vibrating object and these are produced as timbre. Frequencies higher than the fundamental frequency is called the overtones because they are at half length and 1/4 of length, and these in the psychological domain is known as timbre. So, overtones are called timbre. Now, if you remember, these are the three things that we have in sound. We have the pitch, which is the frequency, we have the loudness, which is the amplitude, and then we also have the overtones, which is partial frequencies, half frequencies, half than the or frequencies higher than the fundamental frequency, and these are called the timbre. Waveform A and B have the same frequency, but different amplitudes, as do waveform C and D. Look at A, B, C, D. Waveform A and C have the same amplitude, but different frequencies, as do wavelength B and D. Waveform E is a periodic noise, while waveform F is one cycle of a periodic musical keynote played on a clarinet. So, this is periodic, this is aperiodic, and so we will discuss that aperiodic, periodic. So, this is my from this tone to this tone is my frequency, and this is my amplitude. So, a vibrating object produces a sound with a regularly repeating pattern. So, when something is vibrating, an object like a tuning fork is vibrating, it produces sound with repeated regular repetition. This is known as a periodic sound. Two objects, but that is not the only sound which is there. So, most vibrating objects they produce periodic sound, but some of them also produces, sometimes they also produces aperiodic sounds. So, two objects rub against each other produce a sound with no regular repetition pattern, and these are called the aperiodic noise. For example, you rub your hand like this and bring it near your ears, the sound that you hear is not periodic, and this is called aperiodic noise or periodic tone. So, periodic sound, these are regularly repeating pattern produced by vibrating objects perceived as ringing or musical in nature, and vowels are periodic speech sounds. So, these two we have not explained, but these two we have explained. And so, most vowels are periodic and most consonants are aperiodic. So, A, E, I, O, U, you can sing this. These are produced by the vibrating cord without any restriction to the air which is sent out by the mouth. So, A, E, I, no restriction, and so you can sing it, but with other things the consonants. So, anything except the A, E, I, O, U in English language is a consonant. So, for example, B as there is a restriction in the sound which is coming out of the mouth, and this is called a consonant. So, aperiodic sound, these are generally produced by consonants, no regular repetition pattern, produced by collision or friction, perceived as noise, and consonants are aperiodic speech sounds. Speech sounds can be broadly categorized into vowels and consonants. Vowels are periodic, which is they are ringing, they are musical character to them. For example, A, I can keep on singing like that. But then consonants are aperiodic and they are noisy. I cannot say T, go on saying T and not lose my breath. I can after a period of time I will lose my breath. There are, however, some consonants which can be produced without friction. For example, the SH, sh, you can do that. The SH noise produced without friction, this is also consonant, and you can do it for a longer breath across your breath. But then there are other consonants like P, you cannot sing it for a longer period of time. So, these are the basics of the sound or the basic of the wave from which the speech is produced, how the speech is produced. Next, we look into how this speech which is produced by the vocal tract, how this is heard by the ear. So, if I ask you this question, how do you hear sound? The answer to this is through my ear, and maybe you will point to this cartilage which is coming out from the head. Now, obviously, this has nothing to do, this is just a directional mechanism, and this part even if I cut out like Van Gogh did, you will still be able to hear sounds. So, this has nothing to do with the ear. The ear perception of sound in the ear actually starts in the inner ear at the inside of a ear. So, basically the organ of auditory sensation is the cochlea, that is the snail like organ inside the ear, in the inner ear, which has hair like structure, which can see or which can perceive changes in sound and then convert these changes into electrical impulses which are then perceived by the primary auditory cortex. The basilar membrane extends inside the length of the cochlea and its hair cells are sensitive to particular frequencies. So, the cochlea has a basilar membrane, it is a two-part system, and so the basilar membrane is lined by hairs, it is filled with fluid. The sound that we are producing, the wave pressure, the waves that we are producing at different frequencies, they are perceived by the cochlear hairs and they are transposed or they are changed into electrical signals which are perceived by the or picked up by the primary auditory cortex through a mechanism. So, cochlea it is an organ of auditory sensation in the inner ear. Basilar membrane extends inside the cochlea, undulated vibrations, fluid of the cochlea. As I said, the cochlea has hairs, the basilar membrane of the cochlea has hairs and it is filled with fluid, and in this fluid the sound waves travel and they are picked up by the hair cells of the basilar membrane. Now, the basilar membrane which you have in the inner ear which actually picks up sound has something called a tonotropic organization. Now, what is tonotropic organization? It means that if you have ever seen a piano, you have high sounds to low sounds. If you play it this way, different frequencies are arranged. So, higher frequencies to or lower frequencies to higher frequency. So, basically what tonotropic organization means that it has sensitivity to different frequencies at one end and lower frequencies at the other end. So, you have the hair cells are arranged in such a way that higher frequencies are perceived at one end and lower frequencies are perceived at the other end. So, that is how the hairs are arranged. The primary auditory cortex is located in the superior temporal lobe and it has the same tonotropic organization as the basilar membrane. So, the primary auditory cortex which picks up the signal from the cochlea, it is arranged in the same way that the basilar membrane inside the cochlea is, which is tonotropic organization. So, high frequencies, and if you ever seen a piano, you have things like this, right. These are the keys of a piano, and if you keep on pressing you will see the frequencies from low to high, it will keep on going. So, what is tonotropic organization? It is a progressive arrangement of cells sensitivity to different frequencies. The primary auditory cortex, this is the region which gets input from the hair cells of the basilar membrane inside the cochlea. So, superior temporal lobe, initial processing of input from the cochlea arranged in tonotropical like the basilar membrane. This is how the ear is. So, when you actually hear something comes here, this is my, so even if you cut this pinna and external auditory canal, nothing happens here. The perception starts or the actual hearing starts here. This is my eardrum. Now, this is a membrane on which the waves will come and bounce, and this is attached to a three-part system which is called the hammer, the end wheel and the stirrup. And so, these wheels, this is the part of the inner ear, and what they do is they mechanically they enhance the wave, and then from here it moves to the inner ear which is the, this is where the cochlea is. Inside this you will have the basilar membrane. Now, in the basilar membrane there are hair like structures which are arranged, and then it is filled with the sound waves, they move into this cochlea or move through the liquid of the cochlea, and these are perceived or these are picked up by the hair cells which are here. These are arranged from 20 hertz to different hertz, right, and so different frequencies are there, right, from 20 hertz, this is the beginning, to 20,000 hertz which is the limit, and can be picked in that way. Hair cells along the base are organized according to the frequency they are sensitive to, with the highest frequency position at the opening of the cochlea. As you can see, this is 1000 hertz, 20,000 hertz, 1000 hertz, 10,000 hertz, 5,000 hertz, 4,000 hertz, 3,000, 2,000, 6,000, 8,000, 6,000, 800, 600, 400 and so on and so forth. These are hair cells which are there inside this. This is filled with fluid, moves here. If it is a 20,000 hertz pitch that you are producing, it will be picked up from here reported to the primary auditory cortex, which actually takes this signal and converts into electrical signal, because inside the brain everything is electrical in nature. Sound waves are converted into electrical signals inside the ear. Now, the auditory cortex is tucked between inside the lateral fissure of the surface, that is still considered to be part of the temporal lobe. The primary auditory cortex is arranged in tonotropical fashion just like the basilar membrane. This is my secondary auditory cortex, this is my primary auditory cortex. It is arranged in the same way in which the basilar membrane is. And so, as you can see, 16,000 hertz, 8,000 hertz, 4,000 hertz, 2,000 hertz, 1,000 hertz, 500 hertz and so on and so forth. And so, the basilar membrane hair cells connect to this different. So, this is the 500 hertz basilar membrane hair cells gives a signal here, electrical signal. From here it passes, primary auditory cortex passes to the secondary auditory cortex, and secondary auditory cortex then makes a perception of it. Basic idea is that they are arranged in the same way like a piano. So, the primary auditory cortex is located in the superior temporal lobe, and it has the same tonotopic arrangement as the basilar membrane. Neighboring cortical regions, including the Wernicke area in the left hemisphere, do higher level processing of the auditory input. So, the Wernicke area then takes in from the secondary processing area and that does higher level processing of the sound. Now, we can't recognize objects and events just by the way they sound. The idea is that sound is enough for us to recognize objects, and so we can recognize objects just by the sound of it. For example, falling glass, the whistling of the tree, we can just recognize objects or object movements through sound. Speech sounds are likewise auditory events that are extremely short duration, yet our ability to perceive them accurately is remarkable. Speech sounds, although most speech sounds are time based. So, basically speech sounds or auditory perception is a time based event. It moves across time, it is a single channel event. And so, what happens is that they are very short duration, but we can perceive them. Think of the last office meeting you have, there is so much sound everywhere, it was all around there was so much sound, but you can very easily in that in that humdrum of so much sounds, you can still perceive different speech sounds from different objects and can locate or can think about what object is making that sound. That is the beauty of the speech system. So, auditory perception unfolds along a time dimension. It happens across a time when the time goes away or it moves in a time dimension. So, you have to perceive it across time, not across space, as in visual perception happens across space, but auditory perception generally happens across time. So, then having said that, having looked at the wave which is the primary source of auditory perception and the apparatus that makes sound or that perceives sound, let us look at the speech stream in itself. When we speak, what really happens? Now, written text, what does the speech stream consist of? So, if you look at written text, let us look at this text, sound results from vibrations, let us look at this text. Now, if you look at it, there are certain words which are close together and there are certain spaces which are there, and so we can distinguish between words. So, written text, they have discrete letters with each word separating through spaces from immediate neighbors, you can know of that. Speech stream, they do not have discrete phonemes and clear word boundaries. Speech is a continuous. So, when you speak, there is no space between it, there is no clear boundaries. Speech is continuous in nature, and so speech is a continuous flow of ever changing frequencies and amplitudes. When we speak on, and so there is always changing frequencies and amplitudes which are moving, there is no gap between that. Speech perception system, they infer intended phonemes and word boundaries. So, it is the beauty of the speech perception system which generates boundaries of where there should be gap in the spoken speech. if you ever look at a spectrogram, which is a machine which converts the spoken speech into its fundamental frequencies, you will see certain regions which are not populated when in speech, in speech output. These regions which are not populated are actually not periods of silence. There are certain consonants which are called the stop consonants, and is basically the stop consonant which is putting that white space in the spectrogram. So, the spectrogram, the spectrogram allows us to visualize the structure of speech stream. Spectrogram is a machine which takes in the speech stream or the sound which is coming out of your mouth, and it projects it, and we can study the speech stream through that. Now, what is a spectrogram? The spectrogram of speech sample consists of alterations of aperiodic and periodic sounds roughly corresponding to consonants over the language. So, when we look at a spectrogram, it actually consists of aperiodic and periodic sounds, which basically is that it is consisting of consonants and vowels, how they are produced by the speech stream, and that is what is the display actually showing. And as I said, the periods of silence are actually consonants which are called the stop consonants. Certain consonants in English language which are called the stop consonants. Now, at the bottom of any spectrogram, the fundamental frequency of the speech is displayed. This is the fundamental frequency of the sound resulting from the vibration of the vocal fold as air is expelled from lung, and which is called the phonation. So, what is phonation? Phonation is the fundamental frequency of the sound which is resulting from the vibration of the vocal fold as air is expelled from the lungs. Sound resulting from vibration of the vocal fold, air is expelled from the lung is called what is called phonation. So, the primary frequency that we have, the fold, the primary vibration that the vocal tract is doing is called the phonation. And then a related term is called the prosody. What is prosody? Now, this fundamental frequency, the rate of vibration of the vocal fold results from fluctuation in the fundamental frequency during an utterance. Now, this fundamental frequency is never constant. The fundamental frequency is the vocal fold vibration, and is different for different people. Now, this fundamental frequency is also not constant, it varies across time, and so or across a utterance, across a speech, and these vibrations in pitch, in frequency is called the prosody. So, what is prosody? The way you speak, when you speak there will be variations in the vibrations of the vocal tract, the frequency of vibration of the vocal tract. Of course, everybody has a fundamental frequency, but this fundamental frequency keeps on changing, and that is what is prosody. So, what is prosody? These are fluctuations in fundamental frequency during an utterance, conveys both linguistic and emotional information, that is what a prosody is. And why is prosody important? Because it conveys linguistic and both emotional information, that is why it is important. So, prosody serves a number of linguistic functions as well as conveying information about the speaker's emotional state. How are you if I say that? How are you if I say that? Oh, how are you if I say that? And so, the same way, the way we speak this how are you, that is basically prosody, the change that I am doing to the fundamental frequency. Everybody has a fundamental frequency, but the change in the fundamental frequency which I am doing, or the change in the pitch, that is what is called the prosody. The prosody stretches or the speech stream reveals bands of high amplitude sound at certain frequency above fundamental frequency. So, if you look at this prosodic stretch or speech stream, the change in the fundamental frequency in an utterance, if you look at that, it reveals bands of high amplitude sound at certain frequencies and above the fundamental frequency. So, there will be some part, this prosody will be high at some part above the fundamental frequency and low at some part. These bands are called formants and result from the fact that the shape of the vocal tract dampens certain harmonics and enhances others. So, formants are what? These are the bands of high amplitude sound at certain frequencies above the fundamental frequency. When you produce sound, it is not always fundamental frequency. Sometimes it is high above the fundamental frequency, sometimes it is low below the fundamental frequency. The bands of high amplitude sound at certain frequencies above the fundamental frequency are called the formants. And why do they come? They happen because, these formants happen because the vocal tract the one which is producing the sound, they dampen certain harmonics and they enhances other harmonics, and that is why you get a formant. They occur during periodic stretches of speech stream, which is basically the vowel. Periodic stretches is yeah, so not the vowel basically. Now, so these are the formants. So, there is this change that you are seeing up in an utterance above the fundamental frequency and below the fundamental frequency are basically formant. The relative distance between the first and the second formant in comparison to the fundamental frequency is used to distinguish vowels. So, how do we distinguish vowels? The change that we see between two alternate formants, and by comparing this to the fundamental frequency is how we distinguish different vowels. Now, periodic stretch in the speech stream may also signal something called a sorent, a sonorant. Now, this periodic stretch may also signal something called a sonorant. So, what is this? This is a speech sound that usually serves as a consonant, but sometimes as a vowel. So, what is a sonorant? A sonorant is basically just like it is we use a formant to distinguish a vowel, we use a sonorant to distinguish a consonant. And so, what are sonorant? These are speech sounds that are usually served as a consonant, but sometimes they also act like vowels. For example, the L, the R, the N and M in English language. Example, the first L, if I write little, the first L acts as a consonant, whereas the second L acts as a vowel because E is silent here. So, I said little, little, I do not pronounce this E, and so this second L acts as a vowel or seems like a vowel, and that is why that is how it looks like. Now, a periodic portion of the speech stream clearly indicates a consonant. So, periodic is vowel, aperiodic is consonant. The first type, there are two types of, the first type of aperiodic stretch, aperiodic portion in the speech stream, which is displayed by spectrogram, is the fricative. Two types of periodic stretches. The first type is called the fricative. What is it? It is a consonant that is produced by constricting the air stream to create friction. Fricative is basically a consonant which is produced by blocking the stream of air which is coming from the vocal cord, so that a friction happens. Try saying S, SH and F. So, S, the way you do it, the hissing sound that is produced here is basically the fricative, and this is the consonant that I am producing, one type of consonant. The second type of consonant that is produced or that can be seen in a speech stream, in a aperiodic speech stream, is called the plosive. And what is the plosive? It is a consonant that is produced by momentarily blocking and then releasing the air stream. So, in fricative we constrict the air stream to create a friction, and out of that the vowel comes in. The second type is we momentarily block the air stream which is coming from the vocal cord and then release the air stream, and the vowel produced out of that is basically the plosives. For example, the P, the D, the T, these are also called the stop. So, basically then there is also something called the formant transitions, and these are the modifications of the formant due to preceding or following consonant. These are transition in the formant. Now, major categories of speech sounds, sound waves, speech sound, characteristics and examples. For example, periodic, vowels distinguished by the first two formants I, O, U, A, Yo, Yo. Similarly, the sonorant, as I said, some of the sonorant can act like a vowel. For example, sometimes vowels act as consonants, and these are sometimes vowels and sometimes consonants. For example, little, river. Aperiodic if it is, then I have the fricatives which are constricted air stream producing friction. Susie has a fever, and similarly if it is plosives, then constricting airstream and then releasing it, airstream momentary blocked then released. For example, pay K today, basic speech sounds. The high energy segments are vowels and the silent segments are consonants. This is my vowels, this is my consonant, which are only identified by the effects that they have proceeding for vowel and consonant, and this is the pronunciation or the spectrogram for the word attitude. The way I say is, this is my vowel, I vowel, as you see, U consonant, this reason. Okay. There are other interesting thing in the speech sound, that is something about the voice onset time, but we will not take that now. We will move on to how co-articulation and aspiration really works. What is co-articulation? Overlapping phonemes in the speech stream produces co-articulation. Preceding or following a consonant modifies a vowel or a formant. So, a consonant modifies a vowel formant by preceding or succeeding it. So, although they are not more than the brief bits of silence, plosives are common in English language and in languages around the world. So, most English languages and languages around the world have something called plosives. And then what is aspiration? It is a puff of air which is accompanying some plosives, distinguishing B from P and T from C. So, let us look at what is aspiration then. Let us consider consonant pairs like B and P. Aspiration is the sound of air which is, or the puff of air which is coming out from the vocal tract. So, how do we distinguish B and P from each other, the consonants B and P, and that is based on the aspiration. So, vowels are easy, but consonants are a little bit difficult. Now, imagine this, put your left hand on the throat and the right hand in front of your mouth and try saying ba and pa. Do that. If you do that, you will notice two things. There is more phonation or vocal cord vibration in ba than pa. So, in terms of the left hand, when you say ba and pa, in ba there is more phonation, there is more vibration in the vocal cord, but in pa it is not. And so, how do you distinguish between B and P? That kind of a plosive. Also, if you look at the right hand, there is a greater puff of air with ba than pa. So, more puff of air and more vibration on the vocal tract. Now, the puff of air accompanying the release of some plosive is called aspiration. For example, if we look at word pairs like da and ta and ba and pa, both of them are accompanied by a puff of air when they are produced, and this air production when producing certain plosives which are certain type of consonants are called aspiration. The two characteristics of phonation and aspirations are generally explained in terms of something called the voice onset time. And what is voice onset time? The voice onset time. So, how are we measuring this between P and B perception? It is in terms of the voice onset time. And what is the voice onset time? The voice onset time is the difference in time between the release of a plosive consonant and the beginning of a vocal fold vibration, or the release of the consonant, the plosive consonant, and the vibration of the vocal cord. The difference between that is what is called the voice onset time. It is the difference between the release of a plosive, a consonant, and the beginning of a vocal fold vibration, the vowel. Now, speech sounds, they do not occupy discrete sections of speech stream, but rather they overlap each other in a process which is known as co-articulation. So, what happens, or what is co-articulation is that when we speak, the speech that we are producing is basically overlapped over one another, and that is what is called co-articulation. Speech sounds are perceived categorically even though they are produced differently depending in the context. So, when we perceive speech, we do not look at the specific sections of the speech, the specific plosives and or fricatives or vowels. We look at speech as a whole and we perceive them in certain categories, that is what is called categorical perception. So, speech sounds are perceived categorically even though they are produced differently depending on the context. So, we categorize certain speech sounds and then we perceive them together. Originally, categorical perception was believed to be a unique characteristic of speech perception. Now, it was soon understood that as a general so categorical perception is a general cognitive principle. Simply put, categorical perception is one way our brains deal with the massives of the real world. If you look at the real world, there is so much sound which is there, so much things which are there, people are talking, things are falling, so many sounds are there. So, the best way for speech perception is by putting categories. So, this is human speech, this is what the brain does is it separates from a different number of frequencies around you. It does what it does is it separates certain speeches and it says that this is human speech, this is object speech, this is the speech of an animal, this is the speech of something, and that is how it perceives. So, it puts them into certain characteristics and that is how it basically goes through the everyday messiness. The speech perception system relies on context to fill the missing information. So, what is categorical perception? Continuously changing stimuli perceived as belonging to discrete sets. We take a number of stimuli and perceive them together. So, speech perception system, they rely on context to fill in missing information from a speech stream that has been marked by ambient noise. In the process is known as what phonemic restoration. When we speak, just to prove that this categorical perception happens, if we are speaking and certain segments of the speech are missing, the speech perception system is able to manufacture or fill this thing, and this is what is called the phonemic restoration. So, filling in missing segments of speech stream with contextually appropriate material is what is called phonemic restoration. So, if I have a context, if I have certain words missing, certain letters or certain parts of letters missing from a speech stream, from a sentence, I can restore that, and that is what is called phonemic restoration. For example, Warren and Warren, they tested this phonemic restoration effect. What they did was, they produced sentences like this: the state government met with their respective legislature, and they put a star here in the S which is missing, conveying in the capital city. This is a sentence they read to people. This is the sentence they read to people, and in this particular word, this missing S was either replaced by a cough or by a silence. When a silence is produced, legislators, this way people are not able to restore the S, but when people cough in between, for example, legislators, in this case people are able to restore the S. So, participants heard gap, noticed who heard gap, they noticed the missing S, but participants heard missing S place cough before or after legislature. So, if you cover it with a cough, then people restore this S, and this is what is called the phonemic restoration. People are able to create the phone back, restore the phone back. So, Warren and Warren 1970, they modified the following sentence by splicing out the WH from this word. So, it was found that the WH from this was splicing out the WH from the wheel, and it was found that the star EEL here people were able to replace that. Now, it was also found out that if I change this thing here, the last word, the context will design how what people are filling in. So, what letters, what phoneme is being filled here is dependent on the context. To prove that, what Warren and Warren did was, they took a sentence like this. It was found out that the star EEL was on the, and when they filled up this last word with XL, people heard it was wheel. But when the last word was shoe, people heard that, or people reported that they heard heel. So, in XL they represented wheel, but in shoe they represented heel, and that is the restoration that was happening. So, it was context dependent, the restoration was context dependent. So, this was replaced by cuff, also XL was replaced by shoe. Similarly, shoe, if shoe was, and if I replace the shoe with an orange in here, people would say, found that the peel. So, P here, H here, and WH here. People were able to replace these phonemes. Now, psycholinguists used to assume that the senses operated independent of each other. It was believed by psycholinguists that auditory perception happens on its own, visual perception happens on its own, and so there is no link between that. But it was soon found out that there is a relation between auditory perception and visual perception, and perceptions of auditory nature are multimodal in nature. In recent year, researchers agree that to the idea that the senses strongly interact with each other to produce a rich experience of the word, and this is called the multimodal perception. So, multimodal perception says that senses strongly interact, produce rich experience. So, when we are producing auditory perception, the visual information is also included in it in the auditory perception, and they integrate together to give up the whole idea of the sentence meaning that is being generated. And to test this, McGurk, what they did was they produced a illusion, and in this illusion they made people hear a particular word. They made people see somebody speaking a particular word, but there was no voice. So, in one case people spoke, and so you can auditorily hear what the person is speaking. In the other case, you can see read the lip of the person which is producing, he is producing a particular a letter or a word. And what they did was they made sure that people hear D and people see G being produced. So, the speaker in the visual form is producing G, in the auditory form the audio that somebody is hearing, he is hearing B. When he is seeing somebody speaking it, what the experimenter or the volunteer is seeing G, and when it was later asked what do you see or what letter was being produced, it was found out that it was in between B and G. What people perceived or experimenters perceived was D. So, somebody who saw somebody producing somebody who heard somebody producing B, or volunteers when they heard somebody producing B in auditory domain and saw him or read his lip, and when they read his lip, the person who was acting was producing G. What later on they revealed, what these two people were producing was D, which was in between B and G. So, speech perception combines both auditory and visual information. This is the first effect, or the first time it was found out that speech perception happens from both the streams. It happens from the visual stream as well as the auditory stream. So, the McGurk effect is an artificially induced illusion in which the auditory information from one speech sound is combined with the visual information from another speech sound to produce the perception of a third speech sound. As you said, they see somebody speaking B and they see somebody producing G. When later on when they were asked what is being produced, they report hearing D or seeing D in between. So, that brings us to the end of this session of lecture number 5, where we looked at how speech is produced for the first time. So, what are the characteristics of speech? So, we looked at the characteristics of a wave, and we also looked at the organization of the human ear which does perception of speech. Then we moved on to looking at how this speech perception is represented in terms of the spectrogram. We looked at how aperiodic and periodic sounds, which is vowels and consonants, are represented, and how these vowels and consonants are perceived, and then it is perceived back by the speech systems. We also looked at speech perception in the multimodal form, and what are plosives and fricatives and other kind of interesting things, how the speech is translated into thought, and then how this the speech stream is actually actually perceived, or how it progresses. And then we looked at how the phoneme restoration effect, which is if certain words or certain letters are not spoken in a speech stream, how they are covered up by the brain. So, that is what we did in today's lecture. When we continue on with this lecture in the next session, what we will do is we will look at how this system actually evolved, and we look at especially children and try and see how this system of speech perception or speech production rather they evolved, and several other interesting facts related to the production of speech. So, till we do that, when we meet next, and till that point of time, it is goodbye and namaste from the studios. Thank you.